P only if Q. This also means P tends to Q. If P, then Q is different, but P only if Q. Right? This also one way of saying P tends to Q. So the same statement we had there. That's why it has to be interpreted as what? 1 minute, I'll take that particular problem. I think, is this problem? No. This is the question, right? See? So we will go swimming only if it is sunny. Only if. So this should be, you should not think this as if it is sunny, then we'll go swimming. We will go swimming only if it is sunny means, it means if we are going for swimming, then it means that it is sunny. So you have to take if we will go swimming or if we are going for swimming, comma, then it is sunny. In that way, if you take, I think this yesterday's that thing will be solved. Shall we do this once again? Shall we formulate this once and do it once again?
Yes, ma'am.
So what are the atomic statements needed for this? 1 minute. New slide is needed. Okay, what are the atomic statements needed? Please tell me. It is sunny this afternoon. Okay, so let us take P as it is sunny this afternoon. Okay, then it is colder than yesterday. That is Q. We will go swimming, right? R is we will go swimming. So you have to be careful with this statement. If P then Q is different from water. You should not take the if P then Q can be read as P only if Q. Right? That way also you should understand. Then if it is sunny this afternoon, then what is the other statement we need? We'll take a canal trip. We will take a canoe trip. Then we'll be home by sunset. We will be home or we'll reach home, okay, by sunset. Okay, ma'am. So once again, please tell me what are all the statements. It is not sunny this afternoon and it is colder than yesterday. So it is not, this means what? Not of P and is colder than yesterday and Q, right? So first statement we have what? Second statement, we'll go swimming if it is sunny. Can you see here and say? We'll go swimming if it is sunny. How to write this? We will go swimming if it is sunny. Hello.
Ma'am,
Are you all?
R tends to P.
R tends to P. Next step. If we do not go swimming, then we'll take a canoe trip. If we do not go swimming,
Not R
then
tends to S.
not R tends to yes. Okay, comma. Then next step. If we take a canoe trip, then we'll be home by sunset.
S tends to T.
S tends to T. So these are all the given premises, right? These are all the arguments, and what should be the conclusion? It lead to the conclusion we'll be home by sunset. We'll be home by sunset is T. So we need to prove that all these statements, it's going to give us a conclusion T. Okay. Okay, we'll start. Serial number. What is the premise we are going to introduce? And what is the rule that we are going to follow. Rule or whatever conclusion we are getting, you can write. Okay. First, what you can introduce. Yesterday you told correctly, right?
Ma'am, not R tends to S and
Okay,
S
not
tends
or
to P.
tends to yes. So whenever we introduce something new, what name should be given? It should be called
Rule
as
P.
rule P. Second, what you can introduce?
S tends to T.
S tends to T. So again, it is rule P. Then
Not R tends to T.
Not R tends to T.
okay, not R tends to T. So what is that actually? It is coming
Rule
from
T.
1 and 2. What
Yes, ma'am.
rule you will use to get that third answer?
Hypothetical syllogism.
Hypothetical syllogism.
Hypothetical syllogism. You have to write the rule is rule T, and also the what rule of inference we are using, that is hypothetical syllogism. Okay, so you can write like this: hypothetical syllogism of 1 and 2. Hypothetical syllogism of 1 and 2 and rule T. Rule T, why we are saying rule T? Because you have derived something newly from the given premises. So when we are introducing the given premise, just say rule P. If you are deriving something from that, you have to call rule T. Rule P, rule T and all of no importance, right? What we are deriving, that is very important. Okay, so far you have used these two. But anyway, I should come to this conclusion, right? Only two you have used. Okay, something more you have to do. What is that? Yes, ma. Not R tends to T you have. After that.
Ma'am, not P or
First you can write R tends to P. Correct?
yeah, R tends to P.
R tends to P. So that is rule P. Then not P and Q is there. It is also rule P. You are introducing something. Then not P and Q. No, not P is also true. Q is also true. So not P. What is this called? Two things are true. From that you are saying one is true. Simplification. Yes, simplification. Simplification of 5. If you want, you write rule T. Then now something you can derive.
R tends to
This and this you can use R tends to P and not P you can use. If you use, what will be
not
the result? Not
R.
not R. Okay, so it is rule T. What rule you have used actually? You are using some rule, right?
Modest tolerance.
Modest tolerance.
Enema?
Modest tolerance.
Modest tolerance. Okay, still our aim is not over. Still something we need to do. We need to get T, right? Can you observe somewhere and say
From 3 and 7.
from 3 and 7 you get T. From 3 and 7 using what you are using?
Modest ponens.
So it is rule T. So hence
You have last 12 to 13 minutes.
the result. So whatever we want, this we have proved. We will reach home by sunset. That is the thing we need to prove, that we have proved. Is it clear? Hello?
Ma'am, can you wait for a minute?
Yes, Pa, if you want, take. Yes, Ma, tell me.
I'm from 5 to 6. How you got once again?
5 to 6, 1 minute. See, what is the meaning of this? Not P and Q. When a statement P and Q is true, P and Q is true is given. So what is the meaning of P and Q is true? P is
Both
also
are true.
Both are true. So from that I am taking not P is true. Not P is also true. Q is also true. So I'm taking
Okay.
not P is true. But not P or Q, no, at the time you cannot use any one is true. You cannot say. But from this you can say. So this is called simplification.
Excuse me, ma'am. In the question in the third part where we took R tends to P. So here, if the word only is not present, means we will go swimming. If it is sunny, then it would be reverse, right?
Yes, yes.
Okay, ma'am.
Okay, shall we move on to the next or still some time you need?
No, ma'am, understood.
Okay. So there are things. What is a fallacy? Fallacy means what? Misconception, right? Resulting from incorrect argument. Fallacy means what? Which is not a tautology. Okay. If professor gives chocolate, then you answer the question. You answer the question. Can you conclude that professor gave chocolate? See, P tends to Q is true. Q is true. Will this imply P is true? No, you cannot say right. No. P tends to Q and P is true. I can say Q is true. Right? If you, professor, see, the statement says that if the professor gives you chocolate, then you will answer the question. So only along with that, if the professor gives chocolate, then I can confirmly I can say you will answer the question. Maybe it may be wrong or right, that is different, but you will answer something. Right? Okay. This is called fallacy of affirming the conclusion. And another one is a fallacy of denying the hypothesis. What is this?
Somebody is asking.
P tends to Q, comma not P implies not Q.
Tell me.
See, if the professor gives chocolate, then you will answer the question. If the professor does not, I'm saying along with that, the professor is not giving the chocolate. I cannot say that you won't answer the question. Am I right? Correct or not? Not necessary. Just think about this here. You know P, Q, P tends to Q. Okay. True or false, false, true, 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 false, false. So here alone it is false, you know, right? Okay. So what is this condition? This meaning of this is P tends to Q, Q. P tends to Q is true. P tends to Q is true. Now all these three cases. Q is true. So in this where Q is true? In these two cases. Right? Hello? Hello? Can you understand or not? So Q is true in these two cases. Please listen 1 minute. Can you understand or not? P, just take the truth table. Right? It is given P tends to Q is true. So I'm just ticking out where P tends to Q is true. Just eliminate this possibility. Only these three possibilities. Because it is given P tends to Q is true. That means you know very well in this particular case it is not true. So P is true and Q is false cannot be there. Okay, I'll eliminate that. Okay. So I'll just remove this. But along with that, if Q, I'm saying the only possibility, if Q is true, na, then P should be true. Is there the only possibility? Is there Q is true? Now you have two possibilities, right? Q can be true. Along with that, P is also false. P is also true. In both these cases, P tends to Q is true. But here they say that P tends to Q is true and Q is true. Now the only possibility is P is true. No, that is not there. Even P can be false also. So that's what fallacy of affirming the conclusion. This is not possible, right? Okay, the second one, again 1 minute. These are all just arguments here. Don't confuse yourself. I'll again take the truth table. See.
Yes. I was replying. What is your name? Okay.
Again, P tends to Q is true. So I am eliminating this. Here also, in this P tends to Q is true. P is not true. They are saying that when these two together happen, the only possibility is Q is not true. I'm saying this is also false. False in the sense, I cannot say that only Q is false. Q can be true also. See, I think you will understand. So P tends to Q is true. In all these three cases, P tends to Q is true. Right? P is false. Among this, where P is false? In these two cases, P is false. Right? So when P is false, they are saying only Q is false. No, Q is also true, right? In that case also P tends to Q is true. So this way of concluding is wrong. That's what this is called fallacy of denying the hypothesis. You cannot deny something when it is true. Okay.
There will be no extension of time. Please submit and go.
This and all I told you already. CP and all I'll tell you later.
No request will be fulfilled. I cannot accept your request. Don't ask
Okay,
me
ma'am.
again.
We'll do this. If it rains heavily, then traveling will be difficult, right? Many, see, they have given a set of statements. Okay. These are all the set of statements. Starting from here. Is it visible? Here. From here till here. These are all the given premises. If it rains heavily, then traveling will be difficult. If students arrive on time, then traveling was not difficult. They arrived on time. Therefore, it did not rain heavily. So, the whatever I have given within brackets, that red color thing, these statements are the given premises. So, from that we are expecting a conclusion that it did not rain heavily. That should be the conclusion, right? So, here what are all the atomic statements involved? What are all the statements that we need to give a symbolical notation so that we can symbolize the given statement, logical statement, right? It rains heavily. So I'm giving that as some P. Traveling will be difficult or traveling is difficult is Q. Then arrived on time. Only these three atomic statements are needed. Using this you can write everything, right? So what is the first statement? If it rains heavily, then traveling will be difficult. That is, if P happens, then
All
Q
are
is
still writing. Please upload
true.
whatever
So
you
P
have.
tends to Q.
There will be no extension of time.
If students arrive on time, then traveling was not difficult. Students arrive on time means what? Yes, sorry, R tends to traveling was not difficult means what? Not Q. So R tends to not Q. Next, one more statement, they arrived on time. That is R. So all these things should give, what should be the conclusion? Can you say what is the conclusion? It did not rain heavily. From here, can you say what is conclusion?
Please upload.
No.
Huh?
Negation of
Negation of P. So how to do this? Can you say serial number, premise and rule?
Roshani Krishna, please upload.
How to start?
You have only last minute. No extension of time. You will lose that answer.
Yes, tell me. How to start here? Let's think about it and say how to start. Which statement you can introduce first? From all these three, I should get not P. So which should be introduced first?
No extension of time. Please mind you.
R tends to negate Q.
R tends to not Q. Okay, then
R.
R. So if you use these two, can you get something?
Not Q.
No, not. So what you are using there actually, from 1 and 2, you're deriving this. What is that called?
Modus ponens.
Okay, modus ponens of 1 and 2. Good. Of 1 and 2. Okay, I'll continue here. Then, so these two you have used already. You are left out with now P tends to Q. Anyway, you have to introduce that. Okay. Something more you can do now. P tends to Q is
You have
there.
less 1 minute.
P tends to Q. Along with that, what you can use?
Not Q.
No.
Not Q.
How many times I have to tell no?
Not Q. So if you use, what is the result?
Not Q will be the result.
Illama, P tends to Q and not Q. If you use, what will be the result?
Not
Not P.
Not P. Okay. What you are using actually there?
modest tolerance.
Modest tolerance.
Modus tolerance of 3 and 4. Good. Modus tolerance of 3 and 4.
I am already off.
So along with that, you can write rule T.
I will not check.
Okay. Okay. Shall we proceed?
No.
Yes, ma'am.
No extension of no. Who is asking?
Okay. Can you try?
Can you once again?
Yes, ma'am. Yes, ma'am.
Sorry? You don't have any network issue.
Okay, ma'am. Thank you.
Okay, ma'am. Can you do one thing? Now, can you try this question?
Enough time you have got. After that, enough time you have. And I have warned you many times, no extension of time. I have
Is it audible, my voice? Hello? Hello?
Yes, ma'am, it's audible.
So can you please do this already? Symbolization, everything is done. Can you complete this and tell me how to proceed? What ways you have used and tell me. What is the conclusion here? Here very important thing here. Show that the following premises are inconsistent. I didn't say about this. 1 minute, please listen everybody. So what do you mean by inconsistent? If some set of statements are inconsistent means, if you are trying to use all the statements together, finally you will arrive at a contradiction. You won't get a conclusion. Instead you will get a contradiction. That means all the statements together, whatever they have given, cannot be true. That is not at all possible. Some way or other you are speaking some absurd statements. Right? Which is going to contradict each other. So that is the meaning that you are going to prove the statements are inconsistent, right? So what are the statements given here? If Jack misses many classes through illness, then he fails high school. If Jack fails high school, then he is uneducated. If Jack reads a lot of books, then he is not uneducated. Jack misses many classes through illness and reads a lot of books. Right? Okay, these are all the statements. We need to prove that all these statements together, it is going to give an absurd meaning. They are not valid. Okay, we are going to arrive at a contradiction. By arguing, we cannot prove anything. Instead, what we can do is we are going to symbolize these statements and we are going to use all the rules of inference, and finally, we are going to prove that what? These statements are absurd. They are inconsistent. Right? So for symbolizing this, first we need to identify the atomic statements that are hidden inside this. Right? So what are all the atomic statements that you can see here? Jack misses many classes. That is one atomic statement. So I have taken it as P. He fails high school. Jack fails high school. So that is Q. And he is uneducated. That is one more atomic statement. I have taken it as R. Jack reads a lot of books. That is yes. Other statements are repeated only, right? So using all these things, I have symbolized this. Okay. Now try to prove this and tell me. Take 2 or 3 minutes time and then tell me. Hello? Are you trying?
Yes.
Are you all trying?
Yes, ma'am.
Hmm. You have to arrive at a contradiction. Contradiction means what? Something like P and not P, Q and not Q. Something if like this, if you are able to arrive, then you can conclude that all these statements are what? Contradicting each other. That is the thing you want to prove. Okay, say, tell me at least how will you start?
We can take P tends to Q and Q tends to R.
Okay. Okay, serial number 1.
Okay. Okay.
Okay, serial number 1. First you are saying P tends to Q,
P tends
correct?
to Q. Yes, ma'am.
Okay, P tends to Q. Rule P. Okay, then next step.
Ma'am, Q tends to R.
Q tends to R. Rule P. You derive something from this?
P
P
tends to
tends to R.
P tends to R. Okay, I call that as rule T.
Number.
What is the rule you are using here?
Hypothetical syllogism.
Hypothetical syllogism of 1 and 2. Okay, ma'am. Go back. We have used these two, right?
Except module 1, module 2 is there.
Something more?
Module 2
What you
is
can
there.
use?
Take P and S and derive P.
Very good. P and yes. Yes.
Module 5 is there.
So P is true.
Module 6.
What is that called? A simplification. Simplification
Module
of
7 is also there.
4.
Except module 1.
Okay. So P and P tends to R. What is the result?
R. Modus ponens. Now we can use S tends to not R.
Okay. Now S tends to not R. You can bring out, right? It's a new thing we are introducing. New premise. Okay. And then you can use these two, right? Yes, Ma, you are correct. You are proceeding the correct way. Tell me.
Then we will get not S.
Not S. How do you get that? P tends to Q, comma not Q implies not P. That is the same here we are using S tends to not R, and along with that, not of the get rule T modus tollens of 6 and 7. Of 6 and 7. Okay. Not S there. To find something which will have underlined something now. P and yes,
P and S, so S should be true, but we are getting not S here.
also yes. Correct. Yes is true. Rule T simplification of yeah, simplification of
4, ma'am.
4. Correct. So then yes and notice from what 7 and 9. Illama. Oh, one page in between it is extra. Yeah, you don't think of that. From S and not S, 8 and 9. Okay. So you are right. This is a contradiction. This is a contradiction. It's a false statement. Okay. Hence, what should you conclude finally? Hence all the premises finally lead to a contradiction. Contradiction. Or you can say the premises are inconsistent. Always you have studied consistent. The system of linear equations is consistent. What do you mean by consistent? It should have a solution. It should have a conclusion. But here, this particular system of statements, you can call that a system of statements, it is not having a solution. It's not having a conclusion. Conclusion is what? Contradiction. They are contradicting each other, so you cannot come to a conclusion. Right? So it is inconsistent. Okay.
Ma'am, can you show the
Okay,
previous slide?
Ama, okay.
Previous one, ma'am, not this one.
Hello.
Yes, ma. Shall I go to the next?
Ma'am, can you
कहाँ?
go back?
Don't see this.
हाँ 12:45 को.
Yes, ma'am. This.
ठीक. शायद टीम्स पर ही वो चालू करेगी, हम तेरे को मैसेज कर देंगे, वो इनवाइट कर लेगा उसके अंदर. हाँ.
किससे बात कर रहे हो? हेलो बेटा, किससे बात कर रहे हो?
मैम मीटिंग है 12:45 को, उसको बता रहा था. सॉरी.
ठीक है, 12:45 पे ही है ना, टाइम है अभी. ठीक.
हाँ. He just called to ask the time. Sorry, ma'am.
Okay, no problem. So can you do this question? Everything I have given, can you do this? Okay. Construct an argument to show that the following premises imply the conclusion it rained. See, the one thing is you don't see the tense here, grammar and all don't see here. Because P here you're assuming it rains. It rained also you're saying. Okay, you can say it rained or it rains, doesn't mean. Doesn't matter. While you're formulating, don't just go deep into the grammar and tense and all, whether it is present or past and all. Can you do this question? I've given you all the atomic statements. Only thing you need to do is you have to formulate this using the atomic statements and come to the conclusion. Try. Okay, have you written these statements symbolically first? How to write the first statement? If it does not rain or if there is no traffic dislocation, then the sports day will be held and the cultural program will go on. R denotes sports day will be held and the cultural program will go on because it should take simultaneously, right? Okay, so what does the first statement? How to write the first statement? Using all these.
Ma'am, not P or not Q implies R.
Not P or not Q.
Yes,
okay, not P or not Q.
Implies R.
Implies R. Okay, then second statement.
R tends to T.
Okay, if the sports day is held, then the trophy. Okay, R tends to T. Okay, good. Then
Not T.
not T. These are all the symbolized statements, right? Okay, now you have to use what? The rules of inference to prove or to conclude that. What is the conclusion we need? Hey, what
It
is
rained.
it rained?
We need
That
P.
T. Can you say how to do this?
It is P.
P, sorry, not T. P. How to do?
Now we can take the first two, apply hypothetical syllogism.
One. I'll take an empty slide first. Okay, first two I have to take. 1 minute. So serial number. Okay, first two. First is not P or not Q tends to R. Correct? Then second one is R tends to T. These two are rule P. Annama, you saying something?
Yes, ma'am. Ma'am, can you go back to the previous slide once? Ma'am, in this, like for R, we have considered sports day will be held and the cultural program will go on. Ma'am, will this not be two different premises?
No. We have to assume that if the sports day will happen, then the cultural program will go on. In that way, we have to assume.
Okay. So we'll just consider it
Because
as.
if the sports day happens, then the culture program will go on. If there is no sports day,
But
then
in the second step,
it is something which is combined together, which will happen together.
Okay, ma'am.
Maybe there may be a stress. It should have been given. You are asking correctly. There should be a stress over there. And then
ma'am,
next.
but in the second statement, like if the sports day is held, but it is not mentioned that the cultural program also is going on. But we are writing R tends to T, ma'am.
That's what, yeah. If the sports day is held, that means cultural program is also going on together.
Okay, ma'am.
Then
We'll get not P or not Q tends to T.
Not P or not Q tends to T. So rule T, what is the rule you are using?
Hypothetical syllogism.
Okay, using hypothetical syllogism on one. Okay, then.
We can introduce not T.
Not T, okay.
Then applying a modest tolerance, we'll get a negation of not P or not Q.
Negation of not P or not Q. That is rule T, modest tolerance of 3 and 4.
3 and 4, sorry. This can be P and Q. This is simplified to P and Q. So P is true.
You have to use De Morgan's laws, right? You are actually using De Morgan's laws.
Yes,
It is like A union B the whole dash. A is not P here. B is not Q here. A union B the whole dash is A dash intersection B dash. A dash is negation of negation P. So P intersection is and. Again negation of negation Q. P and Q. So rule T. Directly here also you can write if you want. No issue. Rule T using De Morgan's laws on 5. Okay. Then so P is true. Yeah. Simplification. From 6 simplification. P only we want to prove, right? Correct?
Yes.
Okay, okay. So I think even if it is not mentioned, if you want to use the cultural program will go on. That as a separate statement also, I think we can prove this. Will that happen? 1 minute, I'll see. Okay, cultural program will go on if I'm giving some separate sentence. I'll check whether it will happen or not. Cultural program will go on. All right. Send a new set of statements will be not P or not Q tends to S and T, then cultural program will go on. Okay, if the sports day is held, if R, okay, R and S here, sorry. R and S, then R tends to, no, this cannot happen. That's what I'm checking. No, pa. Without that, it cannot happen. Then you cannot bring out the conclusion. Okay. Not needed. Okay, shall we try all these things which are inconsistent, all these things? Oh, time is up. Okay, ma. I'll stop here. So we'll prove this in the next class. I think time is at 12:27.